are in listen-only mode.
Good afternoon, everyone. Welcome to this afternoon's webinar, the OpenStudio Overview. I'm your instructor for today, Chris Walbach, the Vice President of R&D from Performance Systems Development. During today's webinar, if you have questions, I would encourage you to use the questions pane of the GoToWebinar screen. We'll have, because of the large number of attendees we have today, we'll have to mute all of the attendees, but I, again, would very much encourage you to type in questions using the questions pane. We'll answer questions as we can throughout the webinar, but unanswered questions will be answered offline, and we'll send all attendees a link to view them. And also, we will be recording today's presentation, and we will post that on our openstudio.training.com website 2 or 3 days from now. So a little bit about PSD. We are an organization with over 30 years of industry leadership in the energy efficiency space, and most importantly, last September we signed an agreement with NREL to become the first OpenStudio training. We are a company that provides training, consulting, program design, and implementation services to utilities, energy efficiency implementers, energy service professionals, and building portfolio owners. A little bit about today's presenter, that would be me. My name again is Chris Balbach, the Vice President of Research and Development. I'm a professional engineer by training. I've worked in the energy efficiency field for approximately 15 years as a design HVACI engineer and an energy simulator myself. I do a lot of training nowadays. I'm also a CMVP trainer, which is measurement and verification for AEE. I'm also the chair of the AEE BISA, Building Energy Simulation Assessment Training. And I'm also chair of ASHRAE's TC 4.7 Data-Driven Modeling Subcommittee. So I have a pretty large background. I've been doing modeling, energy modeling for about almost 15 years now as a practitioner or a trainer. So today's webinar has 3 major purposes. The first one here is to raise the awareness of OpenStudio in general. Many of you on the website, on our webinar, may be aware of OpenStudio, but it's, as you'll find in the next few slides, it's actually rapidly changing, and I want to take today's webinar to again share some of the features and functions that OpenStudio can perform. I also want to discuss the current capabilities of OpenStudio version 1.2.1, which is the current release. And again, I want to invite feedback from the audience. Even though you are muted, your feedback is encouraged, is welcome through the question pane on the GoToMeeting sidebar. So our agenda today, we have 90 minutes scheduled, and I want to be very appreciative of your time and make sure we started on time and that we do end on time. This is a brief overview of the talking points we're going to have today. The way we're going to work the webinar is we'll cover the first 2 bullets. Starting on the third, we'll have a little bit of time set apart to address questions that come up for that topic. So we'll address questions that come up for data interoperability at that point. We'll address questions that come up for flexibility at that point, and so on and so forth. So again, I want to make sure that I encourage you attendees to enter questions and get us feedback as much as possible. Now, we're here to talk about OpenStudio, and again, the main point of this whole webinar is to share the possibilities that are now able. It's actually possible for us to develop rapid, low-cost, and reliable energy modeling. We'll talk a little bit about where we've been first. And this slide shows at the bottom, I'll give credit to the website where this is a master's thesis, one of Dr. Jeff Haverhill's students. The title of the thesis is Origins of Analysis Methods in Energy Simulation Programs Used for High-Performance Commercial Buildings. In my experience, it's been by far the best document to start to understand how do we get here? Where are we? Where do we come from with respect to the history of energy simulation programs? And we're really still in our infancy. This whole scene started in the mid-'60s, and so we're 60 years old roughly. We're not that old. And you'll see over time, since the 60s, what's really happened to our industry. Well, certainly components have changed, and we started off with mainframes, and we moved to PCs, and then we moved to laptops, and now we're into tablets and things like that. But one thing you'll notice is the simulation code really hasn't changed a lot. Many of our Many of our most popular simulation engines are still using code that was generated in the mid-60s. And one of the things, if you stop and think about it, here we are in 2014. What has really changed in the last few years in our society? And you might think things like cloud computing, things like massive parallel simulation capabilities. These are starting to influence our daily life, and you'll see here in a few slides again that OpenStudio is the first in my experience that's actually opened that up into energy simulation. And it's really a game changer. It's really a game changer for the way that we simulate buildings faster, cheaper, and better. So we'll talk about OpenStudio, and I'll start off by saying it's a fast-moving train. You'll notice here at the bottom of the slide, just sometime in the last 24 hours, the last release of OpenStudio was uploaded to the NREL website. We're at version 1.2.1 as of today. There are new releases every 2 weeks, approximately every 2 weeks, based on a sprint schedule, a development sprint. There are also major releases scheduled every 3 months. So this has been a fairly fast-moving train that we've been on. I've been following this train for about 2 years now, and I've been watching it develop. I've been watching it grow over time. And, I guess OpenStudio version 1.0 came out in fall of last year. It was sort of the tipping point for me, where I actually realized that OpenStudio had become a useful piece of software. It was no longer just a demonstration software toolkit. It was actually useful for me in my daily work, and I started to move towards it and migrate it, and then of course we've just gone deeper from there. So the takeaway from this slide again is that it's unlike most energy simulation software engines and tools. This tool, OpenStudio, is on a rapid development path. So before we start the presentation, I want to go a little bit deeper into some common language so that we're all talking about the same terms. And I'll use the word OpenStudio Ecosystem throughout the presentation, so I want to explain what I mean by that. So when we talk about OpenStudio, we're actually talking about two different things. We're talking about OpenStudio, number one, as a software development kit, which means software can be developed on top of the OpenStudio SDK. Number two, we're talking about OpenStudio as an ecosystem. And by that I mean it's a collection of applications that can be used to build energy models. Today's presentation is really going to focus on the second set of OpenStudio, the applications, the 5 applications that can be used by users in their daily workflow. And 3 of those applications are on this slide. When we talk about OpenStudio, there's often confusion. What do we really mean? Well, we mean the plugin for Sketchup, the OpenStudio plugin for Sketchup, the OpenStudio application, which again is a standalone executable, it runs on your machine, and the OpenStudio PAT, which stands for Parametric Analysis Tool. Again, another application that runs on your machine. Those 3 applications work together as an ecosystem to help one build form and fabric for an energy model, add HVACI systems, service hot water systems and controls, and then finally set up and complete a study, a modeling study. Very powerful standalone applications. There are 2 additional applications in the OpenStudio ecosystem. One is called Run Manager and one is called Results Viewer. And again, you can see Run Manager is set up so if one wanted to manage local runs on a local cluster or a local network, they could do that with Run Manager. Much of that logic is incorporated within PAT, the Parametric Analysis Tool. And then the second application is the Results Viewer, which is a standalone application that lets us view the results that OpenStudio generates. Important note here that OpenStudio generates database output. It's a SQLite database that Results Viewer reads in and provides carpet plots, 2D plots, things like that, graphical viewing of the data. So now we're into the core of our presentation today, which are why move towards OpenStudio? What's different about it? And we'll spend the next hour or so talking about the key differentiators of the OpenStudio ecosystem. And just this is the highlight slide. We're going to cover data interoperability, connection to powerful external engines, flexibility, ease of use, workflows which enable leverage, and a committed development path. And it's my belief, it's my opinion that these differentiators really are the key features that let us build rapid, low-cost, and reliable energy models. I've been, again, building energy models for almost 15 years now, and I've been looking for these kind of differentiators in a piece of software, and I've yet to see them combined in a single tool in the way that they've been incorporated into OpenStudio. So we'll talk about them in great detail in the next slides. So the first differentiator we'll talk about is data interoperability. You'll see on the slide I've listed OpenStudio in the center, and I have a number of arrows pointing in and out of OpenStudio towards other data objects, whether it's EnergyPlus, GBXML. At the bottom left you'll see Radiance. At the bottom right you'll see the SDB XML, which actually feeds into a tool called CBEC-COM 2013. This is a slide that shows how OpenStudio is not a standalone proprietary object model. It was built from the ground up to communicate with other tools. And clearly, EnergyPlus was built to communicate with, but also other external tools through such data object models as GBXML or SDD-XML. And this is actually a really important feature, because it means if you have a lot of models that are existing in a tool that can generate GBXML, okay, we can push those into OpenStudio and not start with a blank slate. You'll see the arrows that I have, the green arrows, those are what are called translators in OpenStudio, and there's what are called forward translators and reverse translators, meaning data can move into OpenStudio or it can be sucked out of OpenStudio, two-way. So OpenStudio is a very powerful tool in that it ships right out of the box, free, open source, and yes, we can move data into it and we can export data from it in these formats. Now that's current. That's OpenStudio version 1.2.1. On the OpenStudio roadmap, we have other translators that are under development, and I've pointed them out here: Contam, eQuest, and ESP-R. And again, it's not, the development is occurring right now. It's not clear to the extent that they will be two-way translators, both import and export. But you can see where this is going. The ability to perhaps take an eQuest model, import that into OpenStudio, and then work from there. That's big leverage. That's huge leverage on existing models that many of us have built. So I'm going to stop for a moment. I'm going to see if anybody has submitted questions on data interoperability, because again, I believe this is an important function of OpenStudio. Let me just take a moment to look at the questions and I'll see. Okay. So we'll move on to the next feature, the key differentiation, which is the connection to powerful engines. So the most obvious connection to a powerful engine would be EnergyPlus. That sort of goes without saying. And why is this important? And many of you, I'm sure most of you, are familiar with EnergyPlus. You know that it's a massively complex energy simulation engine. It's got over 500,000 lines of code, and it's 4,300 pages of documentation and growing. It's complicated. OpenStudio exists as an abstraction layer on top of EnergyPlus. That alone is a key feature, but the second feature is that there's a major rewrite of EnergyPlus underway as we speak. And that might be what we call E Plus 9.0, or it's not clear what will be named right now. Regardless of what it will be named, the transition from EnergyPlus 8.1 to EnergyPlus, we'll call it 9.0, will be seamless if we're using OpenStudio. So that the ability for OpenStudio to act as an abstraction layer on top of EnergyPlus really protects us as users from many of the changes that are happening in the EnergyPlus object model. That might not sound like a big deal, but it actually is. If you think about it's time to convert from EnergyPlus 8.1 to 8.0 or what have you, all the things that have to be updated, that's all done behind the scenes by the OpenStudio development team. Our OpenStudio models don't know the difference. We just continue to use them. The second powerful engine that OpenStudio is connected to is Radiance. And for those of you who aren't familiar with Radiance, it's a state-of-the-art ray tracing algorithm, software that and used mostly for daylight analysis. And it's a rather complicated slide I have up here. It would take some time to explain it, but the high-level explanation of this is that there's a general recognition that the daylighting algorithms that are used in our tools today, EnergyPlus in particular, are insufficient for analyzing natural light contributions to our energy models. And if that's true, okay, well, we should use a better tool. Why don't we use Radiance? So the OpenStudio team, again, built a two-way connection to Radiance. And the really unique feature about that is it shares the object model. So no more post-processing of my eQuest results into, say, some tool like Spot or something, and then importing a schedule back into my energy simulation tool. We've tightly coupled Radiance into OpenStudio, which then is into EnergyPlus. And that's a huge deal for folks who are interested in natural light contributions in their designs. And it's really interesting how that works. I want to make it real clear here. This is not, the integration with Radiance and OpenStudio is not meant to replace lighting design in any way, shape, or form. It actually doesn't require IES files or lighting distribution files. It is more meant to help us understand the natural daylight contributions of a particular form of a space. So it's very easy to actually do a radiance analysis within OpenStudio. You do the same sort of things you would do for your thermal model. You build a space, you specify lighting power, of course you specify the fenestration, the punched openings, what have you, and the depth of the room, and all of that. You specify the locations and control methods of your sensors. Same thing you would do if you were doing daylighting analysis in EnergyPlus native. But now you click a button and essentially you run Radiance. There's some configuration that you can choose to configure Radiance if you want to. And what will happen is OpenStudio will spawn off a Radiance run, and then Radiance will create output that OpenStudio will suck back into it, and it will create a schedule that will feed into your EnergyPlus model for the subsequent EnergyPlus run. So it's actually a user, it's hidden from the user, but what we get back out of this again is ray traced results for a design that's looking to improve natural light. Very powerful. So OpenStudio again integrates with the Radiance version 4.2, and it's a seamless integration, essentially hidden from the user. And the third engine that I'd like to talk about here, and we'll talk about it more later in the slide, is that OpenStudio connects to the Amazon EC2 cloud and the Amazon Web Services. And basically what the OpenStudio team has done, they've built a connection to that that hides all the complexity. It's very, very simple for a user to create an account, an Amazon EC2 account, set up a credit card, and begin running simulations on the Amazon EC2. And again, we'll talk about that in some more detail later in the presentation. I'm going to stop for a second and see if there are any questions that came up about connections to external engines that we could address at the moment. So we have a question here. Can you tell us who is working on interoperability with eQuest so we can follow up directly to learn when this capability might be ready? Okay, it's a great question, and it's my understanding that the NRCan team is working on this. Natural Resources Canada is working on this translator, and I do not know what their schedule is. I do not have any information, but we can look on the OpenStudio roadmap and you can see that it says possibly for fiscal year 2014 that this translator will be finished. Second question, do you think data interoperability would also extend to commercial softwares or be limited to free modeling software? Well, that's a great question, and I would say that data interoperability using standards like GBXML or the SDDXML standard, they're just standards for communicating information. So certainly anybody could build a tool that would import or export GBXML or import or export the SDDXML, and there's no real constraint on that. Okay, the third question, when will eQuest interoperability be available? Again, I would say that goes back to the first question earlier. The OpenStudio roadmap says that it's scheduled in fiscal year 2014, which ends in September of 2014, and NRCan is leading that effort. Okay, I think I'm going to stop with questions now. We'll move on to the next section. We'll talk about flexibility. So one of the main features of OpenStudio is its inherent flexibility. It was built from the ground up with this as a key feature. And actually what we'll talk about on this slide, it has nothing to do with OpenStudio. It's a separate project that NREL is working on. You'll see the address at the bottom. NREL, it's bcl.nrel.gov, and the BCL stands for the Building Component Library. Now the Building Component Library, for those of you who aren't familiar with it, is a cloud resource. It's a warehouse, if you will, where one can store either components or what are called measures. And those measures could be stored, again, either in a private manner or a public manner, so such that they can be reused. And in particular, OpenStudio has built a connection to the Building Component Library, both for components and measures. Now, why is this important? Well, this allows us, again, to reuse components that were built by others. So it's a very powerful structure that exists in the Building Component Library. supporting both tagging, commenting, and versioning. If you're familiar with, say, Angie's List, it works very similar. You or I could log in and say, I think this component, its quality is very poor, I think it should be improved, and here's my recommendation, and that recommendation becomes the next version. So it's an external cloud-based resource for reusable components and reusable measures that can be used in the OpenStudio ecosystem. Just one note on that, the building component library is actually simulation agnostic. It's not, there's no reason why it couldn't be used to support other simulation engines. At this time, I believe it has components that support the OpenStudio ecosystem only. So let's talk a little bit more about measures, because this is really a strong feature of OpenStudio. And when we use the word measure, be very clear what we're talking about. A measure is simply, in its simplest form, a measure is a description of how one would like to change their model. So a measure might be as simple as, oh, I want to change the window U value, window SGHC, window size. I want to change one window, I want to change all windows. It's just a formal description of the change that I would like to make to my model. And a measure is described in OpenStudio using what's known as a Ruby script. And measures can actually interact with users through what are known as arguments, so you can get user input to influence a measure as well. So it's a very, very powerful way of interacting with the OpenStudio ecosystem. This slide is really shown that is trying to show that there's three types of measures that are what are known as OpenStudio measures, which change OpenStudio objects. There are another category of measures called EnergyPlus measures, which change EnergyPlus objects. Then there's a third category of measures called reporting measures, which allow us to create custom exports, custom visualizations of results, and it's separate from just changing an OpenStudio or an EnergyPlus object. So this is a key feature of OpenStudio that if one figures out how to leverage this, it's very, very powerful. And finally, these measures can be stored either locally or they can be warehoused on the cloud on NREL's BCL servers. Now measures, you might say, well, okay, he mentioned that measures for Ruby scripts, that's starting to sound like software development. I'm a little bit concerned. Well, here, we're looking actually at an example of a measure, an example of the Ruby scripts that are used to create measures. And PAT, the Parametric Analysis tool, includes a wizard to help users create their own measures. So if you have experience, for example, writing a Visual Basic for Applications macro, if you searched Stack Exchange and gotten help on how to use a method in VBA, things like that, you have the capability to write your own measure. It's not like you're writing low-level C++ code. You're writing in a scripted language. It's Ruby, and you often have code you can look at and copy, modify, edit, things like that to create your own measures. So it's very, very powerful ecosystem for creating your own changes to your own models. Now the unique thing about measures is that there's, what I mentioned it a couple slides ago, there are actually public measures and there could be private measures. And the library of public measures, which exists on the NREL Building Component Library for use in OpenStudio, is growing rapidly. You can see on this slide we started off with a little over 50 in December. As of today there were 74 in there. And as of March 2014 there's a queue of 173 additional measures that are being developed to be inserted into the public area of the Building Component Library. PNNL is also adding measures that are used by the DOE Asset Score, and if you stop and think about this, you say, well, why does this matter? Well, here we go. We have a first example of reuse. No longer am I having to rebuild my own one-off code to try to reproduce something in a model. I'm reusing code generated by others. I'm reusing measures generated by others. And frankly, if they're generated by NREL or they're generated by PNNL and they're on the Building Component website as public measures, we can be assured that they're of high quality. So very rapidly can I now apply a measure to my model just by simply fetching it from the BCL and be confident that it's going to work. That's a different approach than has been done in the past with any modeling tools that I'm aware of. So we're leveraging the cloud here for reusable components and reusable measures. Now I mentioned measures, the 75 measures or 74 measures that were available today. what NREL has done is they've built a taxonomy for measures, and this is just a graphical representation of that taxonomy. So one could think of, I have measures that are people-schedules, or maybe they're measures that affect the envelope, or there's a taxonomy here. And most of those are very easy to understand, but there's actually a new category of measures that I've highlighted in the center that I want to talk about a little bit more, which are reporting measures. And these reporting measures are really game changers for those of us who are practitioners. It's my experience and my belief that one of the problems with our industry is we have a lot of people out there building models of essentially poor quality. And it's not because they're doing it on purpose, it's because maybe the practitioner just doesn't know any better. It is possible within this OpenStudio ecosystem, within the context of a measure, to build what's known as a QA or QC measure, reporting measure, that can check model inputs. I've given an example here where we might write a measure that would check, for example, space lighting power densities, and it might check average weekly full load hours versus some limits that are defined within my measure. And those limits might be configured depending on what's known as a space type. So an office has different limits than a warehouse, has different limits than a hotel room. And, you know, toward the bottom of the slide, you'll see these limits can actually do things. They can halt the process. They can generate an external file. They can generate a warning or a flag to the user. This is an excellent framework for implementing what I call best practice QA/QC. And it's not only on checking model inputs, it's also on checking model outputs. And this has been one thing in my experience, again, with working with a lot of modelers, trying to teach new modelers, is frankly, sometimes they just get into a space where they don't know what they don't know. And so they just keep going. And this is a framework where we can implement rules and essentially check modelers' inputs and check modelers' outputs. If you pass the checks, we can consider this a quality model. That's very exciting. That's very exciting for making I think, our industry move forward, because we can give access to modeling to, you know, a much greater, much larger audience than had it previously, and we just overlay quality on top of it. So let me stop right now here, and we'll see if there are questions I can address with respect to flexibility. I've got a question here. It says, when you are talking about measures, one of the problems with most energy modeling software is the inability to compare geometric trade-offs. Does OpenStudio have an easy ability to compare different geometries? So the answer to that is actually yes. It is possible to write a measure that articulates geometry. You can rotate, again, you have full access to the OpenStudio object model, which means you could do something as simple as rotate the building. You can increase a wall area, increase envelope properties. You have full access to the OpenStudio API if you want to write a measure. And then further than that, if the OpenStudio API doesn't present you with what you're looking for, you have full access to the EnergyPlus IDF as well. So very good question. Another question? Okay, I think that's all the questions we have for this section. We'll move on to the next differentiation, which is ease of use. So, and we're going to talk again, ease of use. We're really talking about the three key OpenStudio applications here that practitioners would use: the OpenStudio Sketchup plugin, the OpenStudio application, and the parametric analysis tool. So I mentioned earlier that OpenStudio acts as an abstraction layer over the top of other tools like Radiance or EnergyPlus or Contam and so forth. And as an abstraction layer, it has some new objects that don't exist in EnergyPlus. For example, things like a default construction set or a default schedule set. And these abstraction layers, if one understands them well, they can be leveraged in a very powerful way. And what they do is they allow a user to build a model where one can just simply substitute or copy, edit, and replace these abstraction layers, and it will rapidly flow through your entire model. We call these resources in OpenStudio language, and we think of them again as reusable containers that hold data that then gets assigned within the OpenStudio object model. And that's a very powerful feature. The second thing that the OpenStudio developers did to enable flexibility and ease of use is they built an architecture in here. This is another abstraction of hierarchy. So you can see in the slides that there's one facility. There could be many building stories within that facility. There could be many space types within each building story, and then there could be many spaces within each space type. In each of these different categories, one could apply those resources that we showed on the previous slide. So if one is careful when they build an OpenStudio model and they apply these high-level resources at the appropriate place in the model, they have a model that can be very rapidly articulated. You can change the schedules throughout the model with one fell sweep. You can change the envelope constructions with one fell sweep. So in terms of ease of use on geometry creation, unless you're importing geometry from GBXML or from an existing IDF file, you're probably ones going to be creating geometry within Sketchup. And even within Sketchup, we have a number of choices of how to create that geometry. All of it uses Sketchup's graphical tools, whether it's Sketchup groups or projecting loose geometry, in other words, drawing a floor plan and extruding it up, or simply creating a new OpenStudio object native, creating a space, creating windows within that space and walls and so forth. So there's flexibility within SketchUp to have different methods for building your geometry, your form and fabric. What's important to know about this slide is it is not possible at this time to take an existing .skp file, a SketchUp file that, say, you get from an architect, and literally push a button, create an energy model from it. You'll have to sketch on top of it. You'll have to do some manipulation within SketchUp to create your OpenStudio form and fabric. However, whatever method you use to do that manipulation, you do retain full access to SketchUp's geometry editing and SketchUp's other features, such as creating camera views and performing section cuts. And there's one other feature that exists in the OpenStudio SketchUp application, which is retrieving space-type resources from the building component library. Now, we talked a few slides ago about resources, those reusable containers that we had. And within the SketchUp plugin interface, there is a measure you can access through the interface to retrieve space-type resources from the BCL. For example, I would like to retrieve pre-1980 hotel climate zone 3A space types from the building component library remotely. Once I retrieve them, then I can assign them into my form and fabric in the SketchUp model, and I can continue building from there. It may not sound like a big deal, but actually if you start using OpenStudio and the SketchUp plugin, this is a very cool feature that again supports rapid, low-cost, and reliable energy modeling. Why? Because when I apply that resource to my model, immediately it flows downstream to many, many inputs very quickly. So generally, users who are using the SketchUp plugin will create geometry, form, and fabric, either using templates or resources that they download from the building component library. And it's important to note that the SketchUp plugin does not contain any HVAC capabilities. In other words, the SketchUp plugin is not going to be where an OpenStudio user would define their HVAC systems and controls and service hot water. It's really form and fabric. One can create ideal HVAC systems, essentially we used to call them purchased air, but that's the limit of the SketchUp plugin. One can use a SketchUp plugin to manage resources, though, and that, again, is a very powerful feature where one downloads those resources from the building component library and then begins assigning them to what are known as spaces within the SketchUp model. And finally, within the SketchUp plugin, that's where users would configure their model for daylight analysis. Within the SketchUp plugin, one would create a new surface, which is called an internal partition. This could be something that would represent, say, movable partitions within your space. They can, of course, create the punched openings, the transparent openings into the space and assign properties to those transparent openings. And finally, configure the daylight analysis. Place a sensor in somewhere in 3D space, configure the strategy for that sensor, such as the set point and its control configuration. All that is done within the SketchUp plugin. The general workflow from there is we move from the SketchUp plugin into the OpenStudio application, where we configure HVAC systems, service hot water systems, and controls. And it's in the OpenStudio application, the configuration of systems and plants, whether it's HVAC or service hot water, is very simple. It's actually a drag and drop and configure approach. There's a number of templated systems that ship with the OpenStudio application. They're very similar to systems 1 through 8 in ASHRAE 90.1 Appendix G. Then there's also the ability to build out from a blank template, say a blank air template or a blank air loop, a blank water loop, a blank condensing water loop, and so forth. And the way one would do that again is they go into the OpenStudio application, they either pick one of the templated systems and modify it, or they pick a blank air loop and just start dragging and dropping and configuring components within that loop. Very, very simple, very rapid. In addition, a feature that OpenStudio 1.2.0 has, and 1.2.1 as well, is refrigeration modeling. It works very similar to the HVAC modeling. It's drag, drop, and configure. And one would say, well, okay, how do you do this configuration? Well, it actually follows the EnergyPlus configuration very closely. In other words, you would drag and drop, and then you would see in the configuration panes the same input objects that you would see if you were modeling EnergyPlus refrigeration objects. So one of the really cool features of both the HVAC system and the refrigeration modeling systems, this drag and drop configuration, is all the node management is done by OpenStudio. In other words, OpenStudio prevents you from dropping, for example, a compressor where it simply can't go. It will block you and say, nope, compressor can't be laid there. Nope, you can't build a system like this. And that intelligence has been built into the interface to prevent you from building unrealistic systems, essentially, unoperable systems. So the general workflow, again, is one goes into the OpenStudio plugin for Sketchup. They build their form and fabric. They go into the OpenStudio application. They add HVAC, service hot water controls, and so forth. And then they move into PAT, Parametric Analysis Tool. And there's a new term we'll use here. We'll call it a seed model, because PAT, the very first thing PAT will ask you, you'll see here, select your baseline model. That's essentially a seed model. And then here's the spot where in PAT one would say, okay, why am I building this model? What is it I hope to learn from it? And we would call that a simulation study. So at this point, we would go into either the NREL building component library and retrieve measures remotely, or maybe we'll retrieve measures locally. We would configure those measures, which think of a measure again as a canned energy conservation measure that we can configure. And we would group those measures together to create what are called design alternatives. This is all done within PAT in a similar to HVAC and service hot water. It's a drag, drop, and configure. There's a final step here, which is collect. And essentially what we're doing is we're creating, again, a simulation study. And PAT was designed, the parametric analysis tool, was designed without limits, meaning that we can create simulation studies here of tens of thousands of simulations. And we articulate those, we create the framework for those here in the PAT tool, and we save that as a separate file. It's no longer an OSM file, it's now an OSP, or an OpenStudio Parametric file. So we're in PAT, we've got our model, we've got our measures, we've got them grouped together to create design alternatives, and now we're ready to do some analysis. And again, this is where OpenStudio really shines. One can run analysis locally on their own machine, or very simply, one can, with a few clicks, go on to Amazon's EC2 website, create an account, basically put in a credit card and set some limits for it, and they will receive what's known as an access key and a secret key. Those two keys go into the PAT interface, and now one can launch simulations onto the cloud. It's really that simple. And so this pre-configured cloud-based analysis right now is limited to only the Amazon EC2. There are plans in the future to extend that to other cloud-based systems, but it's very simple to configure EnergyPlus / OpenStudio to now run on the EC2 cloud via parallelization. Just as an idea of what's happening when we go to the EC2, because it's a whole new world for us to be moving within. It's not really a static world. Pricing can change daily, and you can see the website there, amazon.com/EC2 pricing. And NREL has built this in a way that we use what's called on-demand pricing, which means when we launch a simulation, it runs immediately. I gave an example here of pricing. It calls for approximately $3 an hour. One can buy on the EC2 an 8-core machine, and that machine, again, could run, let's say, for example, something that would take 15 minutes to run locally, 15 minutes to run that machine, a single simulation. You could run 4 of those in an hour, and you could run 8 cores, so I could run 32 simulations in 1 hour. Think of it that way. For $3, I bought myself 32 simulations. That's really interesting economics to start to think about, because I don't even want to think about how much time I personally have spent waiting for simulation engines to sit there and clock and hopefully they finish. And Maybe I'll set it up and come back tomorrow and it crashed somewhere in between. And, wow, now we're really into this new way of thinking where we want to spend our time as analysts analyzing the results, not simply waiting for them to calculate. And if you stop and do the math here, this is a huge, huge leverage. This is a very big deal, putting calculation on the cloud in the hands of simple practitioners like you and I. So I'm going to stop here for a moment and see if there are any questions about ease of use that I can address. And I don't see any, so I'm going to move on a bit here and go to the next section of our webinar, which is to talk about workflows within OpenStudio and how they enable leverage. When I talk about that, what do I really mean? I mean the goal here for all of us, I boil it down to as simple as faster, cheaper, better. How do I build a model faster, at less cost, and of higher quality? And how does OpenStudio help me do that? Well, I look at it this way. The workflows that OpenStudio really supports, and I can say there are three use cases, if you will, on the left. An early design or pre-design, maybe we'd call it schematic design, where the goal of what we're trying to do here is really drive load optimization. I can use OpenStudio for that to very quickly build models using templates and resources. I can set up a parametric run in PAT that would give me some sweeps on geometry, on window properties and envelope properties and shape and form. And then I could actually also look to see what space types might be best suited for what areas of the building, just to optimize internal gains. All that's really internal gain load optimization. I don't really need to know what kind of HVAC systems are in my building at this point. I'm just trying to drive load optimization. OpenStudio can really support studies that they're really geared for that. Now maybe I've gotten further down the path. I'm in what I would call a little further down the new construction path where, okay, I've got to build something that's compliant. I've got to build an ASHRAE Appendix G model to compare to or something like that. Well, again, using OpenStudio, I can very simply extract and fetch compliant materials and constructions from the NREL BCL, ASHRAE 90.1 materials, depending on what climate zone I'm in and so forth. I can also very quickly build Appendix G compliant HVAC systems using the drag and drop HVAC system configuration. And now I can set up studies in PAT, Parametric Analysis Tool, where I can look at varying things like HVAC systems and control points. And not only that, I can actually start to look at life cycle cost analysis as my result to come out of those studies. And those are configurations that are in many of the measures that are on the NREL BCL, life cycle cost analysis inputs. Also within the measures that exist on the BCL, I can very easily generate the information that's needed for lead templates. That's actually a measure. And my goal here in this use case would be really to try to drive some kind of feedback to the design team to get investment beyond simply code compliant construction. The third use case I have here at the bottom is a retrofit or existing building case. And I would say OpenStudio supports a workflow here that I can very easily generate existing geometry. I didn't show this, but it's actually possible to go into Sketchup and the Google's Building Maker or the 3D Warehouse and extract geometry. I can pull in geometry from Google Earth and sketch on top of that. So I can get a lot of data off existing buildings without ever touching the building. And that's very powerful for retrofit situations. In addition, I can, a function of OpenStudio 1.1, I can import existing energy bills into my OpenStudio model. And I can calibrate my model to a defined standard, whether that's ASHRAE Guideline 14 or FEMP 2.0 standards. Those are all built into the OpenStudio application. And then also, I think what's very interesting about the retrofit case is that I'm not necessarily evaluating measures on life cycle cost analysis. I might be evaluating simple, what I would call behavioral measures or even retro-commissioning measures, very low cost, fast payback, trying to blend those together into an optimal package. And of course, I can reuse ECMs as measures from the building component library to do that. So the goal here of the retrofit modeling is really not to go beyond code. It's really to say, I have a certain amount of money, how do I best spend it? Optimal investment. In each of these cases, it's possible to use lots of models and lots of we'll call them prototype or models to create even benchmarks or some way that I can compare my progress to. For example, it would be very easy for me to create an ASHRAE 189 compliant model that I could say, in a perfect world, if I could get to 189 standards, that's the benchmark. Let's set that as our goal and evaluate again our progress in either of these cases towards that goal. So one of the big leverages I see for the OpenStudio ecosystem is its attempt to do what's called crowdsource. And it's an attempt. It's really, we'll see how well it turns out. I told you that the measures are climbing from 56 to 75 in the roadmap for measures. You can see here on the component side, there's quite a few components that are in the building component library, over 33,000. And there's nothing preventing you or I or anybody else from adding to either the components or the measures. So this is a serious, if these tools grow, if the component library and the measures, or I should say as they grow, it becomes even more powerful for reuse by others in the community. I'll point out at the bottom there is a roadmap that's published by NREL for the OpenStudio product, what's going to be in version 1.3, 1.4, and so forth. And there is a commitment in that roadmap to continue to grow out the measures in the building component library. Now, this is an interesting feature I want to talk about, which is a part of OpenStudio 1.2, which is interactive web reporting. Essentially, what's happened is OpenStudio has built a connection to what's known as a D3.js, or a JavaScript library of D3. Bottom line, it lets us very easily take data, which is created out of our OpenStudio models, and present that data in very creative and interesting graphical and interactive formats. And we do that by essentially authoring web pages. This is an example of a report that ships in OpenStudio 1.2.1, and you might recognize this report. It looks very similar to the output from eQuest. But if you look underneath the skin of this report, it's a web page. It's a web page using the D3.js library and using the data that exists in the EnergyPlus SQL output to create these stacked bar charts and the table that you see, the two tables that you would see in this report. So it's very easy once one has that data to transform it into other ways of presenting said data using the D3 library. And this is going to be an interesting feature, I believe, because it wouldn't be hard for us to take that report we saw in the stack bar chart that we're also familiar with, and transform it into things like difference charts or day-hour heat maps, or even one of my favorites, the circular heat chart. If one goes to the website at the bottom here, which is just a gallery of D3 objects, you'll get a sense for what's possible. And it's been my experience that of all the good things we do as energy modelers, one of the things we don't do very well is communicating our output, communicating our results, trying to get action out of all the work that led up to this point. And what OpenStudio has really done is they've made it possible for us to transform all of this data that's coming out of OpenStudio into some actionable reports. And I think that's a very interesting and powerful feature. Here's an example again, because when we start to talk about running on the cloud, we start to talk about our PAT runs, we're running on the EC2 cloud, we have to start to think a little differently about how we visualize these results. What we're looking at is the OpenStudio Cloud Management Console. We're looking at an example of what one could view if they did launch a PAT run on the cloud and how they can actually see what's happening. So this is a brush plot. You can see on the far left axis someone has brushed a little section of the data, and all the runs that fit into that particular building rotation are highlighted. The other runs are grayed out behind it. And you can see on the far right axis is the output, which is energy, EUI, source EUI. So it's a very rapid way, again, of viewing what's happening within a number of cloud runs. This is a PAT run that was launched. And again, within the OpenStudio's cloud servers, we can view things like what's happening within optimization. I don't know if some of the folks around the webinar are familiar with bopt, which is a local tool. It runs on a local machine, and one can perform EnergyPlus optimization runs on bopt and see something like what we're looking at here. Well, it is now possible with OpenStudio 1.2.1 to do similar analysis using OpenStudio and PAT on the Amazon EC2 cloud. In the old days, you might say, well, you know, I'm going to have to run a full-blown parametric analysis, brute force, this multi-dimensional study to try to find some optimal solution of some function that I write, some sort of objective function. Now, it is possible within OpenStudio to, yes, write that objective function, and then also select an optimization function for finding it, and launch it, and literally watch Amazon Cloud compute the simulations and watch these fronts develop over time, and then say, okay, I'm ready to stop now. I can stop. I can conclude what there's meaning in this, and I can see the front. I'll stop right now. That's actually very, very powerful feature that's just recently been added to OpenStudio, and I look forward to seeing what people do with it. So we'll stop here at the Workflows and Enable Leverage section and see if there are any questions that were submitted. And okay, I think we'll move on to the next section. There were no questions. So I'll talk about the committed OpenStudio open source development path. You know, there's a lot of words there. Let's be real clear up front right now. OpenStudio has been and will continue to be an open source project, which means that any and all of us can look at the source code on GitHub today, and we can reuse that source code, and that is the way it has been, the way it will continue to be. In addition, in the past, we've seen folks like the Department of Energy be the key funders for OpenStudio, and there's recently been a commitment from not only the Department of Energy but also NREL to continue to develop OpenStudio. And you can see that again by looking at the OpenStudio roadmap. This is not something that's going to go away in fiscal year 14. There are plans for fiscal year 15 and so on and so forth. This is a long-term commitment to continue to build out the OpenStudio ecosystem. And there's two reasons for that. There's what I started off this presentation saying, that OpenStudio is a software development kit. Underneath all of these applications we were looking at, the PAT and the Sketchup tool, there is an SDK that anyone can build on top of. And functionality will continue to go into that. We've also seen signs from the Department of Energy that they will exclusively use OpenStudio for their simulation. So unlike a lot of tools that I've followed over the years, I've said, well, you know, it might last 2 or 3 years and suddenly it's not supported anymore. I don't feel that way about OpenStudio. I do see that there's a long-term commitment here to continue to develop it, and which means I need to be following it because it's actually got some really interesting functionality. This is a slide I'm showing here from the April 2013 DOE BTO review, Building Technologies Office review, and it's a snapshot of what I believe DOE's vision of all this is. And the first thing I'll say is that you look and you see OpenStudio in the middle, and that blue box represents the applications that we talked about. It represents the SDK that we talked about. It's the OpenStudio ecosystem. You see all the action going on around it. There's a lot happening here. And again, that reinforces to me that this is not a short-term play. This is a long-term play for Department of Energy and NREL to continue to build out the OpenStudio ecosystem. You'll see on this slide the connections to the building component library. You'll see on this slide connections to the Technology Performance Exchange, which I haven't talked about today. You'll see a lot of interesting things on this slide telling us where OpenStudio is going. So again, that reinforces for me the intent that OpenStudio is not a flash in the pan product here. It's a long-term play. So on this side, I want to talk about our commitment, PSD, and our commitment with NREL as also a long-term play, which is to support OpenStudio training and support services. I mentioned at the beginning of this call that we were the first organization in September of 2013 to sign a licensing agreement with NREL to support OpenStudio training and support services. This is the first of our webinars that we've given out to again show the community what is OpenStudio, what can it do, what might it do, how does it work. And we intend to deliver this webinar every 3 months along with the OpenStudio major releases. In addition, we are planning some trainings, which I'll talk about in a few slides. If I would say next steps for you guys, if you haven't already, I would highly encourage you to download the Sketchup 8.0, either free or professional. Download and install EnergyPlus 8.1, which is the current version of EnergyPlus. Download and install OpenStudio, either the current major release 1.2.0 or the minor release, which was again released this morning, 1.2.1. I would encourage you to create an NREL BCL account, and then you can download measures from the NREL Building Component Library that can interact with OpenStudio, and then essentially begin experimenting. Build some shoebox models, pull some measures in, create a very simple local pat run, create an Amazon account if you'd like, and actually if you control your usage, the Amazon usage is free up to a certain limit. There are also some other sources for you. The YouTube, NREL has created a YouTube channel to support OpenStudio with about 50 or so YouTube videos explaining how OpenStudio features work. And there's also an OpenStudio support forum at openstudio.nrel.gov where both you can search support questions by others and also post your own. I mentioned again that OpenStudio releases new major releases every 3 months. We will be updating this webinar. We're shooting for April 17th of 2014, and we will cover new features that will be a part of OpenStudio 1.3.0 in that webinar. So there's lots of ways for you to get started here and to start seeing if OpenStudio is the right tool for you. In addition, some folks might choose additional training if you want to get up to speed quicker. We are sponsoring open market trainings both in Philadelphia, Pennsylvania and in Washington, D.C. in March of 2014. Folks can register for those trainings at openstudio.com. And those are really user-focused trainings to get people up to speed, get them using both the OpenStudio Sketchup plugin, the OpenStudio application, and PAT via the cloud to start being able to manage their own simulation studies. In addition, PSD is offering OpenStudio consulting and support services. I list 4 of them on the right. If you go to the openstudiotraining.com website, you can click on some links. If you have opportunities you think where we might be able to help you in this, please go to the website and give us a holler. Let us know. Okay, we're approaching the end of the content that I have for this webinar. I think I'm going to see if there are any questions here for the moment. And okay, don't have any. I have one that says, is OpenStudio completely open source? And I would say to that, yes, OpenStudio is completely open source. You can go to GitHub and you can log in, create a GitHub account, and you can see the OpenStudio source code. And actually you can fork it or branch it if you like. I have a question, are there any third-party development going on? That's a tough question to know. I'm sure there are third-party development projects going on, but it's hard to know because OpenStudio is so open. It's hard to know who is doing what with what. But I'm certain there are third-party development efforts going on using OpenStudio. I can't really name them. Okay. Other questions? When will we know if BPI CEUs are available? Well, that question I'll address afterwards. Okay, does OpenStudio have access to the EnergyPlus multi-zone natural ventilation routines? The question there, and at this point the answer is no, it doesn't. And if that's a feature you would like to see, I would encourage you to go onto the OpenStudio website, and you can go to the roadmap, and at the bottom there's actually a Google Docs document where you can add that to the feature list. Are there any good resources out there that show the translation of OpenStudio objects to EnergyPlus IDFs? Namely, the translation between multiple spaces to a single thermal zone can be quite confusing, especially given the template hierarchy and inheritance behaviors. That's a question. It's actually a fairly complicated question, but it opens an answer, which I'll say. The OpenStudio API is also public domain, and one can go onto NREL's website, the openstudio.com, and look and review and read the API. And the API would show, the API documentation would show how that translation occurs. I don't have time to show you exactly where it is, but it is located and described in the API. Okay. Okay. Does OpenStudio need to be certified in order to use in lead EA modeling credits? It's a good question. I'm not certain how to answer that because OpenStudio is using EnergyPlus 8.1 as the engine underneath it, and EnergyPlus is certainly acceptable by USGBC. So I'm not sure. I'm not exactly sure how to answer that one. I know I would say because EnergyPlus 8.1 is being used that it would be accepted. The question here, are packaged HVAC systems available? So this, in the OpenStudio application, there is an HVAC wizard, and within that wizard there are a number of templated systems such as systems 1 through 8 in the ASHRAE 90.1 Appendix G system descriptions. And so it is certainly possible to use those templates and configure them to represent packaged systems. And even within those templates, you can swap out whether there's a gas furnace or an electric furnace or steam coil or things like that. So you can pull down a template and then edit it further. So yes, you can use the templates to create packaged systems. Okay, I'm looking for some other questions here for a moment. Will this presentation be sent to us? And the answer to that is yes. This webinar will be recorded, and we will post it to the OpenStudioTraining.com website. And in addition, there's a number of questions that are a little bit more detailed that I'm receiving here that I'm not going to be able to answer as part of this webinar. However, I will try to answer those in a document that I can send out and attach to the emails you'll be receiving. Okay, I have a question about what are the graphical reporting capabilities of PAT? Is there a good comparative options other than the cloud tracking graph that you showed earlier? At this time, the Amazon Cloud Console has built into it some graphical reporting that I showed you, the graphical brush plot. The future releases of OpenStudio will have additional graphical reporting options for PAT, and actually that's part of the March release, March 2014. Is there a site where I can watch someone input and conduct a simulation? So I would say for that, if one goes to the OpenStudio channel on YouTube, there's a series of videos that guide users through the modeling exercises, starting from getting geometry in using Sketchup and the different methods one can use Sketchup, all the way to configuring a PAT run and looking at results. Okay, do the HVAC templates allow smart defaults like automatically applying ASHRAE 90.1-2007 for climate zone 5? Or do you have to go in and adjust COPs, etc.? It's a great question. And right now at this point, the templates that are built into OpenStudio and the defaults do not really allow, for HVAC, do not really allow you to go in and create what is being suggested here, like smart defaults. However, it would be very simple to use the measure articulation to create a measure. And all that measure would do is to override whatever the template did and override them with the default values to use. It's a very simple and powerful use of a measure. Okay, I have a question here. Can you speak to the similarities and differences versus the Synergy project? I could say a few words about that, and I'll just keep them to the OpenStudio in general. Synergy, which is also a free EnergyPlus interface that folks can download, Synergy uses the building component library, but it does not use any of OpenStudio's SDK. It does not use the OpenStudio API. So Synergy does not really allow you to extract measures from the BCL and apply them to your model in the same way that the OpenStudio ecosystem would allow you to do that. However, Synergy does connect to the NREL BCL to pull components, and components meaning constructions and materials and so forth, into the Synergy model. So there is a connection to the BCL, but other than that, I'm not aware of any connection that Synergy has to OpenStudio via the OpenStudio API. Okay, that's a great question here. Are there auto-sizing capabilities for HVAC systems? Meaning you add the components to your HVAC system but don't know yet what the size of coils are, so on and so forth. Okay, great question. And yes, in the OpenStudio application where one would configure HVAC, the opportunity for configuring an option which is called auto-size is there. So there's a button, a radial button, you just select auto-size. It's a little bit dangerous, of course, for a retrofit project and so forth, but actually it's the default in many of the templates is that equipment is auto-sized. So that feature is there in OpenStudio. Okay, any other questions? Here's one question. Are there any good YouTube training videos available now on measure creation? And I'll say that what there is an OpenStudio measure documentation, measure creation document. There's a Word doc, measure creation guideline. And that would get you started. There's also, within the parametric analysis tool, there's a template which will get you started, give you the core Ruby code needed to build a measure. And just to talk about that for a few moments, and this is a great opportunity, it's like with a little bit of external training, one can be up and running and building measures very quickly. The other option for building measures quickly is to just look at something that's very similar and alter it. And so looking at measures that are in the public domain from the NREL BCL, pulling them down, studying them, and making small changes is another way to quickly build measures. The question here, will a user's manual or online self-paced training program be provided at some point? Well, that's a good question, and I'm glad we're looking for questions like that to determine what the market, is there a market for that? Because right now there's very little support out for OpenStudio, and we here at PSD are trying to change that. We are trying to offer open market trainings. We are trying to see where is the need so that we can develop something that would fill that need. So thank you for asking that question. I have a question here. Are there plans for incorporating advanced CFD analysis into OpenStudio beyond ePlus's abilities? Not that I'm aware of. And of course, I'm not connected as close as the development team. I'll try to pass that to the development team and get a better answer. The question here, is there a way to automatically fetch the appropriate weather data for a given station, tapping into NOAA, NCDC resources, for example? Well, there isn't, no one has created a measure that would do that, but it's certainly within the capabilities of OpenStudio's architecture for someone to create a measure to do exactly what you're describing, and that would be a measure that would contain in it Ruby code that could go out and fetch data from NOAA or NCDC or wherever and build a EPW weather file that could be substituted into your model. That possibility is there, but no one has done it to my knowledge. Okay. Okay, folks, I think we're going to stop the webinar now. The questions I have remaining are fairly detailed in their origin, and they would require me to get into the OpenStudio interface and show how to configure certain objects and things like that, which I don't really want to get into on this introductory webinar. But I would encourage you all, again, to download the latest versions of both EnergyPlus and OpenStudio, get the account on the NREL BCL, and start playing around. Start configuring some pattern runs, create some design alternatives, and see if this would fit into your workflow. Keep in mind here, what we're trying to do at the end of the day is find ways to build models better, faster, cheaper. So whatever I'm doing now, is there a way to do it quicker, of higher quality, and at lower cost? And feel free to, again, to reach out to us at, I have my email address here. If you have questions, feel free to reach out to me directly. We will host this webinar again on April 17th of 2014, and we look forward to joining you at that time. Thank you very much for your time today, folks. Take care.
The organizer